Hello everyone, and thank you for joining us in this EMWorks webinar. We shall show you how to use EMS and SolidWorks to simulate axial flux machines and obtain valuable design insight early on in your product lifecycle. Our agenda is as follows: a brief discussion about our products and services, followed by the main technical presentation. After the technical presentation, we will brief you about licensing, services, and various learning resources offered by EMWorks. Then comes the questions and answers period. At that point, Dr. Kabir will go on stage and answer your questions. You may then type your questions in the chat section. All of your questions will be answered. All of our products are integrated into SolidWorks, the #1 3D CAD package. Some of our products are equally integrated in Autodesk Inventor. Why? There are a couple of reasons, including, we want to concentrate our effort on what we know best. Electromagnetic simulation. We don't want to reinvent the wheel. In other words, why should we develop a CAD while there are excellent professional CADs? Developing a CAD requires much more human and financial resources than a simulation software like ours. Indeed, all simulation companies that made the mistake of developing their own CAD ended up with a primitive and even mediocre software. Why bother about learning a new primitive CAD? Just use your professional CAD and start simulating right away. You can easily collaborate with other departments in your company since all of you use the same CAD model. Some companies that have their primitive CAD claim that you can import files from popular CADs such as SolidWorks or Inventor. It is true, you can import. However, oftentimes you would need to heal, stitch, or clean the geometry because of compatibility issues. Furthermore, if and when you need to make the smallest modification, you must start all over again. We hope that you understand now why we stayed away from developing our own CAD and, instead, relied on the professional CADs. We believe that we convinced you. You may ask now, what are the other companies that provide an electromagnetic software package that are fully integrated in a professional CAD such as SolidWorks or Inventor? Look no further. EMWorks is the first and the only company that provides electromagnetic software as add-in to SolidWorks and Inventor. As a matter of fact, the integration in SolidWorks dates back to 2007 and in Inventor to 2012. Consequently, we have more products integrated in SolidWorks which are all gold certified. Our products and services are as follows. EMS is a 3D electric and magnetic field modeling software for frequency ranging from DC to few hundred megahertz. It covers many applications like insulators, cables, bus bars, permanent magnets, actuators, circuit breakers, transformers, and motors. HFWorks is an electromagnetic simulation software for RF, microwave, high frequency, and high-speed electrical and electronic devices. It covers many applications including a wide range of antennas, resonators, filters, connectors, and waveguides. EMWorks 2D is a 2D and axisymmetric electric and magnetic field modeling software for frequency ranging from DC to few hundred megahertz. It covers the same applications as EMS. Motor Wizard is a template-based motor design software. It offers analytical and finite element analysis for BLDC and permanent magnet motors. In addition to these solvers, we offer several multi-physics modules including motion, stress analysis, thermal analysis, electric circuits, and ECAD. Let's move now to the feature technical presentation.
Welcome again to EMWorks webinar series, Simulation of Axial Flux Machines in EMS and SolidWorks. Electrical machines are either radial flux or axial flux, The radials are well known, well understood, and have been used for more than 100 years. On the other hand, the axials are relatively new but experiencing a higher and higher demand, especially in the automotive sector. As their name implies, the magnetic flux direction relative to the machine rotational axis of each type is different. Consequently, in the radial machines, the magnetic flux follows a long path as it goes from the rotor poles to a stator first tooth, then through the yoke to the stator next tooth and back to the rotor poles. Whereas, in the axial machine, the flux has a shorter and direct path as it goes from the first pole to the second pole through the stator core and through air, and that is a big deal. Consequently, the axial flux machine provides a higher power density, torque, and output voltage using less steel, thus, a smaller machine size. In this webinar, we shall show you how to use EMS and SolidWorks to simulate an axial flux permanent magnet machine having a 24 poles double-sided rotors. Since EMS is an add-in to SolidWorks, the #1 3D CAD software, the creation and modification of the geometry is as easy as a pie. We shall give you a quick overview on how to create an EMS study and link it to a SolidWorks motion study. Then, we will analyze the results from several studies that have different materials or other input parameters. Before creating a SolidWorks motion study, make sure to activate the motion add-in as shown. Click OK. To create a motion study, right-click below the motion area as shown and choose Create a new motion study. Click on the motors icon and choose Rotary Motor. Select the face of the rotor as shown. Under Motion, choose Constant Speed and enter 500 RPM. Click OK. Enter 0.05 seconds for the end time of simulation and zoom to fit. Click Play to pre-review the motion. Motion study is complete and ready to be coupled to EMS. To add a new EMS study, right-click on the project name and choose Transient Magnetic. Click on the Coupling Analysis tab and check Motion Coupling. At this point we are ready to couple the EMS study to the SolidWorks motion study. Under Motion Coupling, choose the desired SolidWorks motion study. Selected the moving components, which are the rotors and the magnets. Under Band Component, choose the band, which is the air surrounding the moving parts from all sides. Please refer to EMS Help to learn more about the band. Click OK. That's it, and that's all it takes to couple an EMS study to SolidWorks motion. Let's apply the material for each body. The stator is coreless. The material for the outer air, inner air, and band is air. The coils are obviously made up of copper. The material for the magnets is N4212. The material for the rotors is mild steel. The magnets have a strength and direction. To set the direction, right-click on a magnet part and choose Coercivity Direction. Choose the Y direction. Click OK. Alternate the coercivity direction between plus Y and Y for neighboring magnets. To add a coil, right-click on the coil's icon and choose Wound Coil. In selected entities, choose the bodies that make up the coil. Under Entry Port, select an interface. Under Exit Port, click Same as Entry Port. Click on General Properties tab and enter 15 for AWG and 180 for the number of turns. Click on the Current Source tab and choose Sinusoidal Current Source. Type 0 for DF, 50 for frequency, 30 for IA, 0 for IO, and minus 0.004 for TD. Click OK. Repeat the same procedure for the other two coils. All input variables are the same except for the time delay TD. It should be minus 0.010666666 for coil 2 and minus 0.017333333 for coil 3. All the pre-processing is now complete, and we are ready to run the transient magnetic study coupled to motion. Right-click on the study name and choose Run. Solving will take around 15 minutes on a laptop since it is a transient study coupled to motion. Let's instead examine existing studies that were run previously. We have the results for 8 studies. Studies 1 to 3 are on load current driven analyses with a rotor speed of 500 rpm and a frequency of 50 Hz using different magnet materials. Neodymium, ceramic, and samarium magnets are used in studies 1, 2, and 3 respectively. We will demonstrate the effect of the magnets on the output torque. Study 4 is no load analysis with neodymium magnets. Study 5 is an on-load voltage-driven analysis with an additional coupling to circuits. Study 6 is an on-load current-driven analysis with an additional coupling to steady-state thermal and core loss function in the rotors. Studies 7 and 8 are again on-load current-driven analyses. The speed of the rotor is 1000 rpm for Study 7 and 500 rpm for Study 8. The effect of the speed on the eddy loss will be demonstrated. Let's examine the results of Study 1 in some details and then compare the results among the studies later. After the run is complete, Results folder is created and contains different type of results. Double-click on Results table to examine lump circuit and mechanical quantities as well as motion results, including force, torque, back EMF, resistance, inductance, flux linkage, current, and energy for each time step or each motion position. All of the results table quantities are plottable as function of time or position. For example, click on the Ty torque component and click Add in the Parameters field. Click on Pop-up Plot. The plot of Ty versus time appears. You can track it, smooth it, print it and export it. You may equally view the listing by clicking on its icon as shown, which you can save in different formats. Follow the same steps to plot any of the table quantities. For example, let's plot the back EMF or the induced voltage for all the coils. To plot the motion parameters, click Plot at the bottom of the table as shown. It shows the angular displacement of the moving bodies as function of time. You may also plot the velocity and acceleration. To close the results table, click Close. The magnetic flux density and magnetic field folders contain the near flux density and magnetic fields in the entire model. From the magnetic flux density folder, we can create different types of plots: fringe, vector, streamline, and 2D plot. Right-click on the magnetic flux density folder and choose 3D fringe plot, no clipping. The magnitude of the magnetic flux density is color-coded, where the red color is the maximum and the blue color is the minimum, as shown on the legend on the right side of the plot. Click on different time step. The values change. Click OK. Right-click on the plot icon and animate. Right-click on the magnetic flux density folder and choose 3D fringe plot section clipping. Check plot on section only. Click OK. Right-click on the section plot and animate versus time. Right-click on the section plot again and animate versus section cut this time. Right-click on the magnetic flux density folder and choose 3D vector plot, no clipping. Click OK. Right-click on the vector plot icon and animate, as shown. Right-click on the magnetic flux density folder and choose 2D plot linear. In the graphic area, click on several points on the model, as shown. The magnetic flux density plot between segments appears. All the plot performed on the flux density can equally be applied on the magnetic field, applied current density, and force density. So much for the field plots. You may generate a report that summarizes all of your work. Right-click on Reports folder and generate. Customize your report and choose either HTML or Words format. Click OK. Let's now compare the results from different studies. While holding the Control key down, select Studies 1 to 3. Right-click and compare results. Click on the Ty torque component and click Add in the Parameters field. Click on Pop-up Plot. The plot of Ty versus time appears. As you can see, the effect of the magnets on the output is significant, where the neodymium magnet gives the largest torque. Samarium is the second, while the ceramic is the last. Follow the same steps to compare the back EMF, which also follows the same behavior as the torque. Let's now examine the no-load analysis. Double-click on the results table and plot the TY component following the same procedure outlined earlier. Since it is a no-load analysis, this torque is the cogging torque, which is relatively small. You can also plot the induced voltage or the back EMF in the 3 coils. As expected, the voltages of the 3 coils are 120 degrees out of phase. Let's now examine the voltage driven with coupling to circuit study. Double-click on the schematic to view the electric circuit used. Double-click on the results table and plot the induced current in the 3 coils. As you can see, the induced current in coils 1 and 3 have almost the same magnitude but 60 degrees out of phase, whereas coil 2 has a slightly larger current and also with a phase difference 60 and 120 degrees from coils 1 and 3 respectively. The torque oscillates around 30 Nm. As for the core loss, it oscillates around 13,000 watts. Let's examine now the steady-state thermal aspects of the machine. EMS has an integrated thermal solver where the thermal loads due to magnetic and current losses are automatically passed to the thermal solver without the user intervention, hence no need to export or import any files or data, and the only thermal boundary condition is the convection to be applied in the air region. The results are also integrated right in the same feature manager tree where both magnetic and thermal results are readily available at your fingertip. Since we have seen already how to visualize and analyze the magnetic results previously, we shall jump straight to the thermal results. Right-click on the temperature folder and choose 3D fringe plot no clipping. The temperature varies from around 57 to 83 degrees Celsius. Depending on the design, such temperature may be deemed inappropriate. The magnets themselves do not have any loss, but since they are in contact with the rotors, they heat up through the thermal conduction mechanism. Again, depending on the magnets used, such temperature may indeed demagnetize the magnets. Last but not least, let's examine the effect of the rotor speed on the eddy loss in the rotors. While holding the control key down, click on the 1000 RPM and 500 RPM studies. Right-click and compare results. Click on the Solid Loss tab. Since the loss is the same in both rotors, let's compare the results for just one of them. Clearly, the 1000 RPM yields higher solid or eddy loss than the 500 RPM study. Upon examining the back EMF, it is also higher for 1000 RPM. To conclude, EMS coupled to SolidWorks Motion and Electric Circuits offers you one-stop design platform where you can look at all design aspects of an axial flux machine in one single integrated environment. The results presented are just few from a plethora of valuable design parameters that can guide you in optimizing your axial flux machine and other electric machines. Thank you for attending this webinar and hope to see you in future webinars.
Thank you everyone for bearing with us. And I hope that you have learned from the feature technical presentation. Let me briefly touch upon the licensing structure offered by EMWorks. We offer 3 different programs: commercial, academic, and startup programs. Each program has its own benefits and requirements. For the commercial program, we offer perpetual licenses. Our licensing structure is usually annual based for the rest of the programs. We have a combination of free and paid licenses for students, academics, mentors, lecturers, and professors based on the program they choose. For startups, we offer a very interesting and generous program that saves you money for other startup expenditures. Learning resources. EMWorks offers you various free learning resources, a standard help and step-by-step tutorials, a demo viewer that gives you a head start by accessing many predefined examples and tutorials, regular webinar series on trending electromagnetic topics. Like today's webinar, we regularly post several application notes, blogs, and videos on our web page and social media channels. An annual user conference where you can exchange views and experience with other fellow users. Paid and free web and in-person training. Monthly newsletter to update you about the latest releases, webinars, and other activities. Support and services. Our support service is the strongest point that I can mention in this presentation. We always have your back before and after sales. We offer one-to-one web demo sessions to give you a head start and shorten your learning curve. You may even run a benchmark for you if you want to skip the trial option. We offer consulting and design engineering services. We may even propose to you a new design as per your requirement or refine and optimize your existing design. Featured customers. These are just few of our respected clients. These big names, that come from various industries, are true testimonial for the quality of our products and services. I encourage every one of you to try our software and experience its power and ease of use. We offer 2 weeks of free trial license. You may opt for a benchmark instead of a trial license. Please visit our webpage at www.emworks.com. Go to our Contact Us page. Fill in your information and submit your request. We will contact you promptly. On behalf of EMWorks, I would like to thank you all of you for attending this webinar. Feel free to contact us after this webinar to get more information on our products. Now we pass to the questions and answers period. Please type your question in the chat section on the right of the screen. I kindly request Dr. Kabir to go on stage and answer the questions.